Here we are, the first polynomial to be factorized using the steps that we were working with in class. To follow this exercise, we need to know how to take out factors, the Ruffini's method, and also we need to know how to solve quadratic equations. Let's go with the exercise. Factoring a polynomial involves obtaining its roots, which means, according to the definition, that we need to look for the values of the x so that the polynomial is 0. Therefore, the roots of the polynomial are the solutions of the equation of this polynomial equals to 0. And this is the reason why we start the exercise rewriting the polynomial x to the fourth minus 6x cubed plus 11x squared minus 6x equals to 0. And then we follow the steps. Can we take factors out? Yes, we can take an x out, and we have x times x cubed minus 6x squared plus 11x minus 6 equals to 0. This is a product which result is 0, which means that any of its factors must be 0, or x is 0, or the polynomial x cubed minus 6x squared plus 11x minus 6 is equals to 0. This is a third-degree polynomial, which is not a special product nor a biquadratic equation. So we are going to use the Ruffini's method until second degree. 1, negative 6, 11, negative 6. We are looking for the roots, which are the numbers that we will place here, and so that when we finish the operations, we obtain at the end a 0. But which are these numbers? The root candidates are the divisors of the absolute value of the independent term. In this case, the divisors of 6, which are plus negative 1, plus negative 2, plus negative 3, and plus negative 6. It's interesting as well that we remember the easy rules for 1 and negative 1 to figure out if they are or not roots of my polynomial. For the 1, we need to sum up all the coefficients of the polynomial. 1 minus 6 plus 11 minus 6, and the result must be 0. It is 0, so 1 is a root of my polynomial. I place the 1 here, and I'll do the numbers afterwards. For negative 1, we need to do 2 additions of every other number, which means that we have 1 plus 11, 12, and on the other hand, negative 6 minus 6, negative 12. And these 2 numbers must be the same. They are not the same, so negative 1 is not one of my roots. Okay, we keep going using the Ruffini's method. 1 times 1 is 1, minus 6 is negative 5, times 1 is negative 5, plus 11 is 6, times 1 is 6, minus 6, 0. So this third-degree polynomial has become into a second-degree polynomial, which is x squared minus 5x plus 6 equals 0. We solve the quadratic equation 5 plus minus square root of 5 squared 25 minus 4 times 1 times 6, which is 24, over 2 times 1, 2. So we have 5 plus minus the square root of 1, which is 1 over 2. And here we have 2 possibilities, one with the negative and the other with the positive. 5 minus 1 is 4 over 2, and 5 plus 1 is 6 over 2. The results are 2 and 3. Great. So we have a 4th-degree polynomial with 4 roots. The roots are the 0 from taking out factors, the 1 from Ruffini's method, and the 2 and the 3 from the quadratic equation. So we have 0, 1, 2, and 3. Now we are going to factor the polynomial x to the fourth minus 6x cubed plus 11x squared minus 6x. And its expression is going to be a product of 4 factors, x minus the root. So we are going to have x minus 0x times x minus 1 times x minus 2 times x minus 3. Before finishing, we need to check that if we do the product, we obtain the same degree, 4. So 1, 2, 3, 4, x to the 4th, yes. And very important, the leading coefficient. The leading coefficient in this case is 1, so we have no problems. In other case, we need to place the number in front of the expression, okay? So this is our decomposition. And that's all. Thank you so much.